Actually, good morning, guys. Myself Chandan Kumar. I hope you are doing well. Today we are going to learn Pythagoras theorems for class 10th. We have already taken two lectures on Pythagoras theorems in which we discuss a few topics of these chapters, and there are few topics which are remaining, so which are going to learn now. Let's see the topics of this chapter. First one is Pythagorean triplet, second one is similarity and right angles triangles, and third one is theorems of geometric mean, and fourth one is Pythagoras theorems, and fifth one is applications of Pythagoras theorems, and sixth one is Apollonius theorems. We will discuss all the topics one by one which are remaining here. We have already learned Pythagorean triplets, similarity and right angles triangles, theorems of geometric means, and Pythagoras theorems. Okay, today we are going to learn applications of Pythagoras theorems and Apollonius theorems. But before we move forwards, I would like to request you please subscribe our channel Study with Chandans and press the bell icons to get the latest notifications related to your classes. And if you like the video, please share with your friends and on social media to enhance the morality of our channels. Okay, guys, to our this topics applications of Pythagoras theorems. Here so we have to understand two important words. First one is application and second one is Pythagoras theorems. We have already discussed about the Pythagoras theorems, which we have told you the square of the larger sides equal to the sum of the squares of the remaining two sides in Pythagoras theorems. Now there is one important word is applications. What do you mean by applications? Earlier I have told you about the applications. Applications means the basics use of our per day life is known as applications. What we use in our lives is known as applications, but here applications means with respect to theorems, with respect to Pythagoras theorems, it means related to the right angle triangles. Here we discuss about the relations between the angles and the sides. This is known as applications of Pythagoras theorems. Okay, guys. Now, here, inner triangles relations between the sides opposite to the acute angles. What do you mean by acute angle? The angles which is less than 90 degree is known as acute angles, and the remaining two sides. Say in the first lines, that relations between acute angles and opposites, the remaining opposite sides of our triangles is known as applications of Pythagoras theorems, and the relations of the opposite sides to obtuse angles. What do you mean by obtuse angle? Obtuse angles, the angles which is greater than 90 degree is known as obtuse angles, with remaining two sides can be determined with the help of Pythagoras theorems. It is known as applications of Pythagoras theorem. We see the applications of Pythagoras theorems by example. First, angle triangles ABC. Angle C is an acute angles. What do you mean by an acute angles? Acute angles, it means less than 90 degree. The angles which is less than 90 degree is known as acute angles. And segment AD perpendicular to segment BC prove that AB square equal to BC square plus AC square minus 2BC into DC, when angle C is acute angles other, then we have to prove that AB square equal to BC square plus AC square minus 2BC into DC. Now we start our proving. First of all, here we take our triangles in which C is a acute angles. We take the triangles ABC and angle C is a acute angles. Let's here let AB equal to C, AC equal to B, and AD equal to P to A whole BC. BC equal to A equal to X. Therefore, BD equal to A minus X. It is because BC is A and DC is X. It is because DC lie on BC. Therefore, BDB A minus X. Our topics in triangle ADB by Pythagoras theorems. In triangle ADB, what we can write equal to P square plus B square, hypotenuse square equal to base square plus perpendicular square. Here our hypotenuse is C, it means C square equal to base A minus X plus P square. Okay, guys. Now C square equal to A minus X whole square, it means a minus b whole square. A minus b whole square equal to a square minus 2ab plus b square. Here we write a minus x whole square will be a square minus 2ax plus x square plus, it will be the first equations of our problems. Now, in triangles ADC by Pythagoras theorems, again in triangle ADC by Pythagoras theorem, so we can write hypotenuse square equal to perpendicular square plus base square. Then we write here b square, b is hypotenuse, AC represented in triangles ADC is hypotenuse. Therefore, we can write b square equal to p square, p is perpendicular, and b square base, here base is DC and DC equal to x square. We can write b square plus equal to p square plus x square. Once again, p square equal to b square minus x square. We can write, why we take p square, it is because in equations first we can see here in equations first we use p square and therefore we take the value of p square. So p square will be b square minus x square and it will be the equation number second of this problem. Okay guys, now come to the substituting the value of p square from second and first. Then we can write c square equal to a square minus 2ax plus x square plus b square minus x square, where p square equal to, we can write instead of p square b square minus x square, what we have write in this equations. Now c square equal to a square plus b square minus 2ax, it is because x square plus x square minus x square will be cancelled out. We can see here. Therefore, c square stand for ab. We can write c square equal to ab square equal to a square will be stand for bc, and therefore we can write bc square, and b stand for ac. We can write ac square minus 2. A stand for BC, we can write BC, and X stand for DC, and we can write DC. Therefore, we can write the equations AB square equal to BC square plus AC square minus 2BC and DC. What we have to prove, we get it. Therefore, the first problem is solved out. When our angle is acute angle, then the sides will be AB square equal to BC square plus AC square minus 2BC into DC. And second examples in a triangles ABC and A angle ACB is obtuse angles. So what do you mean by obtuse angles? The angles which is greater than 90 degree, angle C will be greater than 90 degree, then segment AD perpendicular to segment BC, and we have to prove here AB square equal to BC square plus AC square plus 2BC into CD. In acute angles, what we have to prove, that AB square equal to BC square plus AC square. Here we have to write minus 2BC into CD. But in acute angles, we have to prove here plus 2BC into CD. Okay guys, now for obtuse angles we have to prove plus 2BC into CD. Now we start. First of all, we have taken our triangles A, D, B, and in which angle we have taken our triangles A, B, C, in which angle C is obtuse angles. It means greater than 90 degree. It will be 120 or something else. Okay, it is a obtuse angles. Now we have taken some perpendicular directions, perpendiculars AD which is on BC, and this is known as P here. Now in the figure, segments AD perpendicular to segment BC. Now let's AD equal to P, AC equal to B, AB equal to C, BC equal to A, and DC equal to X. Therefore, DB will be A plus X. What will be the DB? DB will be A plus X. It is because BC is A and DC is X. The whole distance from D to B will be A plus X. A plus X. It will be A plus X dB. Okay. Now, in triangles ADB by Pythagoras theorem, so we know that h square means hypotenuse square equal to perpendicular square plus base square. So here we write for triangles ADB, hypotenuse is AB. For that we can write here c square equal to base plus x, a plus x whole square plus perpendicular square is p square. Therefore we can write here p square. Now c square will be equal to a plus b ka whole square. It means a square plus 2ax plus b square. Here we can write for b x square plus p square. It will be the first equations of problem number 2. Okay, see what is common here in ADC. Perpendicular is also common here for the both triangles ADB and ADC. Therefore we can separate P square. Again by the Pythagoras theorem, so we write here h square equal to P square plus B square. H is here B square plus equal to P is P square plus base square equal to x square. So we can write here B square equal to x square plus P square. What we can take commons in it? P square perpendicular is common in both triangles, which is AD. Therefore we can write here P square equal to B square minus x square, and it will be the second equation for the problem number 2 or examples number 2. Substituting the value of P square from second equations in first equation, then we can write C square equal to 2ax plus b square. Right, 2ax, x square plus x square minus x square will be cancelled out. In first equations x square is plus, and in second equation x square is minus. Therefore it will be cancelled out. We can see here. Okay. Therefore C stand for AB. So we can write here for CAB square equal to A stand for BC. We can write BC square plus B stand for AC. We can write here AC square plus 2 and A stand for BC. It means BC into X stand for CD. So we can write CD. Here we got AB square equal to BC square plus AC square plus 2BC into CD. What we have to prove? We prove here. What do you mean by Apollonius theorems? Apollonius theorems, the relations among the sides and medians of a triangle. This is known as Apollonius theorem. What do you mean by medians? Medians means the lines which divide, the line segments which divide the other lines of a triangles into equal parts is known as medians. Okay guys, here we have to find out the relations between the sides of our triangles and medians of our triangles is known as Apollonius theorems. Now we see here by examples we can watch it. In a triangle ABC, if M is the midpoint of side BC, then we have to prove that AB square plus AC square equal to 2AM square plus 2BM square. Now here we find the AB square plus AC square equal to 2AM square plus 2BM square by midpoints of our triangle ABC. Here we have given our triangles ABC in which AM is midpoints and AD is perpendicular on BC. Okay guys, M is the midpoints of side BC. Then we have to prove AB square plus AC square equal to 2AM square plus 2 bm square. Then constructions draw segments AD which is perpendicular on segment BC. Now prove if a segment AM is not perpendicular. If I say that if I assume that AM is not perpendicular to segments BC, then out of angle AMB, sorry, just wait here, guys. AMB and angles AMC, AMC, this angle and this angles. We talk about these two angles. Okay, guys. One is obtuse angles. First one is obtuse angle and second one is acute angle. Other angle is acute angles. Then angle AMB, for angle AMB is obtuse angle and angle AMC is acute angle. Okay. From example first and second, so what I have told you in examples number first and second, for acute angles I have told you what I have told, AB plus MB square plus 2BM into MD. I have told you for obtuse angle, okay, which is greater than 90 degree. For acute angles I have told you AC square equal to AM square plus MC square minus 2MC into MD. It will be the second equation from second examples. Now we can write AC square equal to MB square minus 2BM into MD. It is because BM equal to MC. Why? We can write here MC for BM. It is because of this is equal to, this is BM equal to MC. It is because of M is the midpoint of BC. M is the midpoint of BC. Therefore, MC equal to BM. Therefore, we can write here AC square equal to AM square plus MB square minus 2. Instead of MC, we can write here, we write here BM equal to BM into MD. Okay, it is a second equation. So now adding equation first and second, we get AB square plus AC square equal to 2AM square plus 2BM square. What we have to prove here, so this is known as an Apollonius theorem. So what we have to find in these equations. Okay, guys. Now come to the example number seconds. Okay. Prove that the sum of the square of a diagonals of a rhombus is equal to the sum of the square of the sides. Here we have given a square PQSR and we have to say that a square of diagonals is equal to the sum of the squares of sides. Okay, guys, we have to prove that. Given that we have given a square PQRS is a rhombus, diagonals PR and diagonals SQ intersect each other at a point T. Now we have to prove that PS square plus SR square plus QR square plus PQ square equal to PR square plus SQ square. Yeah, otherwise QS square. Now then prove diagonals of a rhombus bisect each other. Okay, guys. Then by Apollonius theorems, we can write here PQ square plus PS square equal to 2 PT square plus 2 QT square. It is by Apollonius theorems we can write here. It is because of diagonals of a rhombus bisect each other. Okay. PQ square plus PS square. After that PT square 2 PT square plus 2 QT square. It is the first equation. So now second equation for we can write here QR square plus SR square equal to 2 RT square plus 2 QT square. Okay, guys, it is the second equation. So now adding first and second equations, we can write here and we can get here PQ square plus PS square plus QR square plus SR square equal to 2 PT square plus RT square, where we have writes both in a bracket, common bracket, PT square plus RT square. It is because it is a PT or RT line on PR line. Therefore, 4QT square. What do you mean by 4QT square? After that, we can write here 2PT square plus PT square. We can write RT as a PT. It is because RT and PT is the divided by a point T, which is a midpoint on PR. Therefore, we can write RT equal to PT. Therefore, we write here 2PT square plus RPT square and plus 4QT square. Once again, RT square, PT square plus PT square, it will be PT squares here. 2PT square equal to 2PT square plus 2PT square, it will be 4PT square plus 4QT square. Now, PT square, 4PT square, we can write here 2PT square whole square, and 4QT square we can write here 2QT whole square. Once again, 2PT means PR, 2PT means PR. It is because PT equal to TR. Therefore, we can write 2PT equal to PR. Therefore, we write here PR square plus 2QT means QS. 2QT means QS, and we can write here QS square. Okay guys, what we have to prove here, PQ square plus PS square plus QR square plus SR square will be PR square plus QS square. So what we have to prove in these problems. Okay, we have proved it. Okay, now we have to do practice it 2.2 and problem set of chapter of Maharashtra board, or otherwise you can check it according to your syllabus. Okay, according to your book, if you got these types of problems, you can solve out. Okay guys, and at the ends I would like to call you, please subscribe our channels if you like the video, and press the bell icon buttons to get the latest notifications related to your classes. Okay guys, at the end, Jai Hind, Jai Bharat.